Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. We are still considering questions under gradients, tangents, and the normal. If this is your first time, kindly subscribe, share, comment, and like as well for more interesting and catchy videos. Let's see how we can appreciate our topic for today. So we have find the values of x for which the gradient function of the curve y equals this is 0. So what I'll do is I'll find the derivative of y with respect to x. I'll have my dy over dx, which is equal to, viewers, if this is your first time, kindly visit my lectures on the previous videos, alright, where I've dealt with differentiation of polynomial functions using the power rule. So here I'm going to employ my power rule to differentiate these. So I'll have x to the power 3 plus 2x to the power 2 minus, I have my x then minus 2 this way. Now we are saying find the values of x for which the gradient function. What is the gradient? My gradient is dy over dx, for which the gradient function of the curve is 0. So dy dx is what? Is 0. So therefore I will equate this to that. Dy dx are the same to be equated. So 0 equals this. I have x exponent 3 plus 2x squared minus x minus 2. Viewers, we can't do anything from here. So this is what? Polynomial and polynomial function. And before we can solve for this, we need to look out for the common factor. Alright, the common factors, so that it will serve as well as the divisor in the course of what? Division of polynomial. Now, so let f of x represent what? The polynomial function, which is what? My s cubed plus 2x squared minus x minus what? My 2. Now, if f of x is equal to 0, then f of x is a factor. Alright, so we are going to test for or look out for possible values of x which, when substituted into the polynomial function, gives 0. So let's say when x is equal to 1, let's start with 1. So my f of 1 equals 1 cubed plus 2 times 1 squared minus 1 minus 2. So I have f of 1 equals 1 plus 2 minus 1 minus 2. Negative 2 cancels positive 2. This takes of this. So I have f of 1 is equal to 0. Because f of 1 is given as 0, then you can say that f of 1 is what? Is a factor. So if x is equal to 1, this is the same as x minus 1 is equal to what? 0. This is a factor. It's a factor. Alright, so therefore, for want of space, I will come here. So therefore, I will say my x minus 1, which is my factor, will serve as what? The divisor. Then my f of, we have the expression x minus 1, which is our divisor. Then our polynomial function, which is f of x equals, we have x cubed plus 2x squared minus x minus 2 this way. Okay, so S goes into x cubed how many times? So we have x squared, because we have s cubed over my x gives what? X what? Squared. So this appears as what? The quotient, alright? Then we will use this to multiply the whole expression again. So we have s cubed, s squared times x gives x cubed, then minus s squared times the negative one gives what? X what? Squared this way. Then s cubed minus s cubed gives what? 0. Then we have 2s squared minus s squared gives what? Positive. So we have 2 here, then minus it gives what? Positive. Alright? So we have what? We have 3x what? Squared. Then we'll drop this down. We have minus x over here. Again, x divides this how many times? We have 3x squared over x. So we have what? 3x. So I have plus 3 what? X. So 3x by x gives what? 3x squared minus 3 what? X this way. So 3x squared minus 3x squared gives what? 0. So we have negative x then minus 3. So this is what will be positive, okay? So we have what? This is what? 2 what? X. Then I will drop this. We have the negative 2. So x divides this what? 2 times. So 2 by x is what? 2x then minus my 2. 2x minus 2x is what? 0. Negative 2 minus 2 also gives what? 0. Alright, so therefore we can say that the divisor times the quotient gives you what? The dividend, okay? So I can clearly say my divisor, which is x minus 1 times the divisor here, which is what? X squared plus 3x plus 2 should be equal to what? My f of what? My f of x. Okay, so f of x is equal to the divisor was, we have x minus 1. Then the quotient was what? X squared plus 3x plus 2. Alright? So we have x minus 1. Then we have to factorize this. So this is the same as x squared plus 2x plus x plus 2 this way. So we have x minus 1. Then, so let's say we have it this way. Okay, so what is common here? X, right? So we have x, then x plus 2, then plus 1, and x plus 2 this way. So I'll have x minus 1, then x plus 1, then since they are common, pick 1, x plus 2. This is what your f of x. So the question is, find the values of x for which the gradient function of the curve y equals this is 0. So therefore, when I equate this to 0, okay, so if I have x minus 1, x plus 1, x plus 2, is equal to 0. Then you can say that x minus 1 is equal to 0, or x plus 1 is equal to 0, or x plus 2 is equal to 0 using the now factor principle. So I'll have x is equal to positive 1, or x is equal to negative 1, or x is equal to what? Negative 2. So the values of x is equal to 1, negative 1,